In this video, I'm going to be reviewing some basic factoring concepts. I will try to be brief. Some of you might be able to do this without my assistance, and that's fine, but this is just kind of a quick overview in case you need it. The assignment will be pages 1, 2, and 3, just the odds, and page 4 and 5 all. So I'm starting the Unit 1B Part A factoring packet. That's kind of a mouthful. So if you'd like, I would just take a moment and pause the video to read this introduction at the top. So go ahead and pause and come back. So prime numbers are divisible by themselves in one only. A composite number is got numerous prime factors. So I have done some prime factorization with you in the past. So for example, they ask you to do the prime factorization for each number. I'll do a couple of even ones. I'm assigning the odds. So number 2 has the number 10. 10 divides into 2 times 5. Those are both prime. That is your prime factorization, 2 times 5. Number 8, for example, if I look at that one, you could break this into 5 times 12 or 6 times 10. So let's say I do this as 6 times 10. You get the same answer either way. Neither one is prime. They're both composite. So if I break this down, 6 breaks down to 2 times 3, 10 breaks down to 2 times 5. I just did that. Do I really care if you write out the factors together? Not so much. I just really want you to be able to practice breaking down the numbers. If you wanted to write it out fancy, it'd be 2 squared times 3 times 5. All right, why are we doing this? We're doing this to hopefully help you find the greatest common factor and then use that. So try number 14. You can pause the video. Some of you may be able to get 8x to the 7th really quickly. Some of you may struggle with that. I personally think it's easiest to do the variable piece. If you look at the x to the 8th, I have 4, 5, 6, 7, 8 x's, and then here I have 7. They both have at least 7 x's. So that means my common variable is x to the 7th. And then 16 and 24 is kind of difficult to break down in a way. This is going to be 4 times 4, which then breaks down to 2 times 2 times 2 times 2. So you have 2 to the 4th. And then here, this is 8 times 3, which is 2 times 4. I'm just going up for space purposes. So then you end up with the 24 is 2 to the 3rd times 3. So here you have 4 2's, here you have 3 2's. This one doesn't have a 3 at all, so 3 cannot be a greatest common factor. But both of these have in common 3 2's. So those 3 2's would multiply together to give you the 8. So it's 8x to the 7th. All right, try 20 and pause it. All right, this one, the variable piece is pretty straightforward. You have x to the 3rd in all of them. Here you have an extra x, here you have 2 extra x's. This is 2 times 3, this is 3 times 3, and then this is 9 times 3 or 3 times 3 times 3. So none of them, one has a 2, but the other 2 do not. They all have at least 1 3, so this is going to be 3x to the 3rd. All right, when you're ready, flip to page 2. Some of these I think are just really confusing the way they're written. This says state the GCF and the other ones say factor out. Take a moment and read the top to yourself if you'd like, and you can pause. For these, you're just looking for the greatest common factor. So the only difference with what you were doing before is that it's written as terms. So you have a plus sign instead of commas. Here, number 2 is just x to the 3rd. This one here, this is a prime number of 3. This is a prime factor of 2. So you don't have a numeric greatest common factor. You would have an x squared though. So those would just be stating the GCF. For the ones here, I'll do this one, number 10. Factor out the greatest common factor from each polynomial. These are the same. So you have 3x squared times something minus 3x squared times something plus 3x squared times something. The 3x squared is your greatest common factor, and then they want you to divide each term by 3x squared. And when you do that, everything gets canceled with the greatest common factor, and you would have 3x squared minus 4x plus 5 remaining. So it's actually a pretty easy question because they gave you the greatest common factor. So for 12, 5x squared is your greatest common factor. So then 2x squared minus 7x minus 6 is the remainder, or your trinomial. Then at the bottom here, they want you to do all the work yourself. So for 16, find the greatest common factor. So number 16 is going to be x to the 5th. And then you would divide x to the 7th divided by x to the 5th is x squared. X to the 6th divided by x to the 5th is just x. And then a negative x to the 5th divided by x to the 5th is just minus 1. They don't ask you to factor further, even if you could. So that's what they're looking for you to do on page 2. All right, on page 3, I'm not going to read through all the instructions here. You can certainly do that, but basically you are trying to find A and B. So you want to find the two numbers that add to 7 and multiply to 10. So that would be 2 and 5. For number 2, this is a little, you have to think a little bit for number 2. You have two numbers that add to 3 but multiply to negative 10. So you need one of them to be negative. So 5 minus 2 is 3, and then 5 times negative 2 is negative 10. So that's what they're looking for you to do here. So you're just going to do the odds. There's some little tips here at the bottom of page 3. All right, and then page 4 and 5, I'd asked you to do all. This is a lot of review. So this is factoring using our grouping method if A is not 1. So remember we did this before where we had the x and you had A times C and B. So we want to factor by grouping. A times C is 10. You want to have two numbers that add to 10, that multiply to 10, that add to 7. So that could be 2 and 5. I think we just did one just like that. So then I would write this as 2x squared plus 2x plus 5x plus 5, and then always check for equivalency. Yes, 2x plus 5x is 7x, so that's good. You're going to take out your greatest common factor here and here. So in the first binomial, the greatest common factor is 2x. So when you divide, you end up with x and 1, so x plus 1. And then here, your greatest common factor is 5. So when you divide, you get x plus 1. They have to be the same. Remember, they have to be the same. If they are not the same, then you did something wrong. So this is going to be in factored form, your greatest common factor of x plus 1, and then 2x plus 5. All right, pause the video and try example 2. All right, so when you do this one, I have a product of 12 and a sum of negative 8. I'm breaking it out into negative 6 and negative 2. Had you done negative 2x and negative 6x, you're going to get a little bit of different work in the middle, but your final answer will be the same. Here, your greatest common factor is 3x. So when you divide, you're going to get x minus 2. Sorry about that. And then here, you're going to subtract out negative 2. And when you divide, you're going to get x minus 2, which is good. These have to be the same. And then I didn't say this for the last one, but after you get your final answer, it is a good idea to check. So I'm getting x minus 2 times 3x minus 2. And then if you check it, 3x squared minus 4x minus 2x minus 6x is minus 8x, and then negative 2 times negative 2 is 4, so I'm good. This one's a pretty straightforward one. So you're going to finish pages 4 and 5 all, and I hope to see you in person or online for our red group on Friday. Thanks, everybody. Bye.